Hey, what is up? Today we're going to look at section 10.3. It's the next step, right? We're going to look at hypothesis testing for a population mean, right? So last time we have looked at hypothesis testing for a population proportion. All right, so we need to remember a few things when we're talking about population proportions and how we're going to test for those with hypothesis testing, right? We had to do our check, right, our three-pronged check, right, of simple random sample, n times p times 1 minus t, p is at least 10, and n is, less than or equal to 0.05 times the population size, okay? All right. So we did do those checks, and then if we did that, what we did was we found the p-value by drawing our normal curve, right? There's their null hypothesis value, right? So h naught, right? And then we would mark off where the sample occurred, find this p-value right here, compare the p-value to alpha, right? And if alpha is bigger than the p-value, we rejected the null hypothesis. If alpha was less than or equal to the p-value, right, then we accepted. Well, I shouldn't say accepted, but we did not reject h naught. All right. And then for a two-tailed test, we saw a second way to do this, to where we made a confidence interval, right? And if the sample statistic x bar was inside this interval, then we do not reject. And if x bar is outside the interval, then we reject it. Okay. All right, so that stuff was kind of an intro to what we're going to be doing today, because it's going to be the same idea, but let's review a little bit before we jump into 10.3, right? So let's go back to section 9.2, right? This is where we were trying to estimate the population mean. All right, so we're getting ready to do a hypothesis test for the population mean, but here's how we were trying to estimate the population mean. We made our confidence interval, right? And for the confidence interval, remember it's centered around the value from the sample, x bar, and then it was plus or minus the margin of error that we had for that particular test. Right? Now, for proportions, it used p-values, right? So it's using the normal distribution. For the population mean, we saw it was a slightly different test we were using. We were using the t-distribution to get our values. So what I want to do real quick is let's remind ourselves how to look these things up. Okay, so this is Table 6 in the back of the book. If you want to look that up, looks like it's on page A13, right, in your appendix. Okay. Now, the way this chart is set up, if you look at the picture that's up there, it has this type of a picture, right, which means it's giving us these values to the right of the curve. Right. So this is area to the right. Right. For the normal distribution, we had the area to the left. Okay. So it's not normal, it's a t-distribution, not area to the left, area to the right. And how we had to look these things up were slightly different as well. Right. So let's remember how to do these confidence intervals from section 9.2. It was x bar plus or minus my t-value times s, the standard deviation of the sample, over the square root of n, and little n is the size of the sample. Right? And we were using the t-value of alpha over 2. So if alpha was a 10% confidence interval or range, then that would be what, 0.10. So alpha over 2 would be 5%, which is 0.05. And we also needed what was called, just to remind you, degrees of freedom. Right? And that's not hard to find. That's just n minus 1. Right? So let me set up a problem for you. Right? Let's see if we can figure out how to find these t-values real quick. Right? So let's find the t-value such that the area under the curve, let's see, is 0.10. And let's assume that the degrees of freedom equals 15. Right? So in terms of the notation we were using before, we want to find t of 0.10. In this case, I'm not dividing it by 2. I'm just using t of alpha here. So t of 0.10 with the degrees of freedom of 15, which some places will denote it like this. Okay. All right, so let me clean off a little bit of work here. All right. So here's what we want to find. Whoops, need this. All right, so here's what our picture is going to look like. All right. I want to figure out what's this area going to be. Okay. Well, let's look up this line in our chart, right? So let me kind of pull this in for a second. All right, so here is our chart, right? If you look at it, just to remind you, this is our degrees of freedom column right here. So in this example, we're looking along the row where we have 15 degrees of freedom, which is this row right there, right? In this case, alpha equals 0.10, which is right there, right? So the score we need looks like it's right here, right? Which gives me a value of, so t of 0.10 with 15 degrees of freedom is 1.341. Okay. All right, so let me see if I can actually blow this up a little bit for you to make it a little bit bigger. All right, so here's our picture again. So again, it was 15 degrees of freedom. Alpha level was 0.10. So you get that t-score of 1.341. Okay. All right. So what we're going to be doing is basically the same thing as we did the last time, only we're going to be using t-scores to help us figure this thing out. And unfortunately, we're not going to be able to get the p-values exactly. All right? These charts estimate them for us, so we're going to get a range for our p-values, but we won't be able to get them exactly. There is software out there that can find those exact numbers for you. So what we're going to do is we're just going to be kind of estimating these p-values. Okay? So let's do something. So what we want to do is we have a check that we need to do here as well. Right? We need to make sure that we have a simple random sample. And then before we did n times p times 1 minus p was bigger than or equal to 10. Right? That's for the proportions. Right? For these counts, what we want to do is this. We want to make sure that we have no outliers. We want to make sure that we have one of the two options here. Either the population is normal or we have a large sample size. And if you remember from 9.2, we said we want at least 30 in here. So in other words, if this is my population, if it's already normal, then I can pull out any size sample that I want. Right? If it is non-normal, or if we just don't know, then make sure you're pulling out big samples that are at least 30. All right? And then the third thing we want to check is the independence ID, again, just to make sure that the population is sufficiently small compared to the population, right? All right, so then here's what we will do, right? So let me check independence, okay? So the first thing we'll do is, and sometimes this will be given to you, sometimes you may need to actually calculate them yourselves, but let's calculate X bar and S, in other words, the average from the sample and the standard deviation of the sample. Right? Secondly, let's calculate our test statistic. right? So we'll call that T0, T naught, right? It's kind of like our z-score. It'll be x bar minus whatever the claim is, mu naught, over s over the square root of n. Right? So again, same style we've been using before. Okay. One other idea I want to convey to you back to here real quick is what happens if it's non-normal and we have small samples. Right? Then we can't do any of this stuff. Okay. So just be a little careful if you have small sample sizes. Make sure the population is already normal. Otherwise, these techniques could lead us to some bad results. Okay. All right. So everything else, again, is going to be pretty much exactly what we have been doing. We could have one-tailed tests. We could have two-tailed tests. So let's jump into these things to see how we can start to look at them. Right? So here is number 6 in our book. Right? Someone is making a claim that mu is equal to 80, and we have an alternative hypothesis that the mean should be less than 80. Okay? So the book tells us in number 6 that we pull out a simple random sample of size 22, and they also tell us this. They tell us the population is normal, which is good because then I'm not too concerned about that small sample size. Okay? All right, so we're pulling out samples of size 22. Right? And what we do first of all is for part A here, we pull out a sample that had an average of 76.9 and a standard deviation of 8.5. Okay? The first thing we're asked to do is to compute the test statistic T naught. Okay? So in this case, again, remember that's x bar minus mu over s over the square root of n. So this is 76.9. The claim is 80. S is 8.5. And the size of my sample is 22. Right? And if you throw all this stuff in there and simplify it, you get negative 1.711. Okay? So that is my test statistic. All right. So that's part A. Part B says we are going to test this at the alpha equals 0.02 level. Okay? So if you remember, what we want to do to either reject the null hypothesis or accept it is this. Right? We're going to try to estimate the p-value. Right? And if that p-value is less than alpha, we reject H naught. If that p-value is greater than or equal to alpha, we do not reject. Okay. Now, unfortunately, again, the way the tables are set up is we can't get that exactly, but we'll see what we can do here. Okay. All right. Now, since we're taking samples of size 22, so since n equals 22, remember the degrees of freedom that we need for our chart is just n minus 1. So in this case, that's just 21. Okay. So here's what we are going to do to try to estimate this p-value. Right? If you go to the line of 21, it looks something like this. Right? So we just went right along the line, and I pulled out the values that were close to this test statistic here, right? 1.711. Again, don't worry about the negative sign just yet. Okay. So if you notice, this is what it looks like in our book. Now, if you go along the top row, this 1.323, that gives an alpha level of a p-value of 0.10. Right. This would be 0.05. This would be 0.025. Right. So that 1.711 number, that falls between these two values right here. Right. So that says that the p-value that we're looking for is between 0.025 and 0.05. Right? So again, this is how we're estimating the p-value. We don't get it exactly, but this is how we are estimating it. Okay? So that's what I know about the p-value. Now, do we reject or do we accept it? Go back over here. We know alpha is 0.02. The p-value is this, right? There's 0.025. Well, how about if you think about it like this? I don't know if this will help you out a whole lot or not, but if you think about a number line, the lower bound for the p-value is 0.025. The upper bound for the p-value is 0.05. And alpha is 0.02, which is right here. Right? So my p-value is bigger than alpha. And if you remember, when the p-value is bigger than alpha, that tells me that I do not reject this null hypothesis. Okay. All right, so you might want to go back and watch this one again and have your book out open to this chart so you can find these numbers to see what's going on. Okay. All right, let's do a two-tailed test. All right. So here is how about number 10? All right. So in this case, the null hypothesis is mu equals 45. The alternative is that mu is just not 45. Right? And for number 10, what's happening here is I'm taking a simple random sample of size 40. Right? So since this is bigger than or equal to 30, I don't care if it's normal or not. Right? So I know all the samples are going to be normal. So that part's okay. Let's see. What else do we know from the information that we're given? Okay. All right, so, oh, by the way, that answers part A. Part A says, does the population need to be normal? And the answer is no, right? Because we're taking large enough sample sizes. Okay. All right, so here's part B. We're told that the average of the sample is 48.3 and that the standard deviation S is 8.5. All right. First thing I want to do is compute the test statistic, T naught. Right? So it's the average from the sample minus the claim over S, the standard deviation, over the square root of the sample size. And when we calculate this number, I get 2.455. So that is my test statistic. Okay. All right, so now here, again, n is 40, so the degrees of freedom is 40 minus 1, or 39. Okay. And what are we testing at here? Let's see. We're going to let alpha be 0.01. Right? So this is a two-tailed test. So here's what we're going to find. Right? We're going to try to find this t-score, right, and that t-score. I guess since it's symmetric, one will be positive, one will be negative. Okay? And since alpha equals 0.01, that means I want the area there to be half of that. So that'll be 0.005. That'll be 0.005. Okay? All right. So let's look this thing up in our chart, right? So if you look up 39 in your chart, you'll see these particular numbers. Right? So those numbers are going along row 39 there. And then if you look up the area in the tail, let's see, for that first one, 2.426, that's where we have an area of 0.01. This one is 0.005. This is 0.025. And our test statistic, 2.455, falls right between these two. Right? So this p-value is between 0.005 and 0.01, which means we get the same thing here for that particular area. Okay? So if I multiply those by 2 to add them together, I get 0.01 is less than p is less than 0.02. Okay. All right. So again, if you think about your number line, let me erase a little bit right here. All right. So if there is my number line, p-value is somewhere between 0.01 and 0.02, right? So it's somewhere in between here. Right? Alpha is just outside it, right? It's right here. Right? So it looks like it just misses it, right? So alpha equals 0.01, and it's somewhere, it's bigger than this, it's less than this, but since it's bigger than this number, I know that we do not reject. Right? Because remember, if you go back to this thing right here, that test statistic 2.455, right? It's bigger than this number. So if we multiply that by 2, that means it's bigger than 0.01, right? So it's bigger than alpha. So in this case, the p-value is bigger than alpha, so we do not reject. And one other thing to remind you about this as well is, remember, for a two-tailed test, we could set up a confidence interval, right? So let's remind ourselves how to do that part. All right, so we set it up like this. It was x bars, the average from the sample, plus or minus t of alpha over 2 times the standard deviation of the sample over the square root of n. Okay? All right. And if you remember here, if we look this stuff up, alpha is 0.01, so this would be t of half of that, so that's 0.005, and I have 39 degrees of freedom. Okay. Look that up along your charts as well. Okay. And if you look that up on your charts, you get 1.685. Okay. So that's what this t-score is going to be. Okay. So we can build our confidence interval like this. It's x bar plus or minus that t-score times s over the square root of n. Right? And if we multiply this stuff out, we get 48.3 plus or minus 3.64. So if we add those together, I get 51.94 is my upper bound. And if I subtract it, I get 44.64 is the lower bound. Right? So this is the confidence interval that we're using. Okay? So if the average falls inside this confidence interval from the sample, we don't reject it. If it falls inside the confidence interval, we do. Right? So here was the average from the sample, and if you notice, it is inside that confidence interval. So since that's inside the confidence interval, again, we knew we weren't going to reject it from what we just did, but here's just a second way to do a two-tailed test. Right? So we do not reject it that way either. So for the two-tailed test, you could try to estimate the p-value and compare that to alpha, or you could do a confidence interval and see if the average from the sample is inside that confidence interval. All right? Make sure you know how to do both ways, though. Okay? All right. I understand it's probably a little bit confusing. That's okay. We'll do some more of these things as we go throughout the week. So let me give you a few of them to practice with. All right, give those a shot. Most of these problems have the information given to you. For 23, for this one, right, you will have to, all by yourself, you will have to calculate the average and the standard deviation from your data set. Right? So it's, let's see, 2, 4, 6, it's 10 data points. So feel free to do it by hand or stick it into a spreadsheet to get your answer either way. Okay. All right. Don't worry about this stuff. We will keep on going through it. See you later.